Welcome to the Explainer. Today, we're going to be data detectives. We're not solving a crime, exactly, but we are going to solve a mystery, one that's hidden inside millions and millions of rows of data.
So, let's just start with this fundamental challenge. You are staring at a massive data set, right? It's just a sea of numbers. You know the answers are in there somewhere, but how do you even begin to find them? It really is like looking for a needle in a digital haystack. Okay, take a look at this chart. Each one of these little plots is a different U.S. airline, and it's tracking daily flight delays over a month. I know, it's a lot to take in, but your eye is drawn to something, isn't it? Look at that huge cluster of spikes for almost every single airline, right around the 17th and 18th. Something definitely happened. The big question is, what?
Yeah, just staring at a complex chart like that, it's not going to get us very far. We need a systematic way to slice through all that noise, to group the information, and start asking really targeted questions. We need a game plan. And the strategy that data scientists use for this exact kind of problem is something called split, apply, combine. It's a really elegant and honestly super powerful way to make sense of all this complexity.
And its heart, the idea is actually pretty simple. Imagine you have a giant box of Legos, and they're all mixed up. You wouldn't try to build something by just grabbing pieces at random, right? No! First you'd split them into piles, by color or by shape. Then you'd apply some kind of action, like counting how many of each piece you have. And finally, you'd combine all that information into a neat little summary. And that is exactly what we're about to do with our data.
So this process just formalizes that Lego idea. Step 1, you split the data into smaller, more manageable groups based on some common characteristic, like the airline or maybe the date. Step 2, you apply a function, something like calculating the average or the sum, to each of those little groups. And finally, step 3, you combine all those results back together into a new and way more insightful summary.
Let's make this super concrete with this tiny table. We can split all this data based on the values in column A. That gives us two groups, right? One group for all the rows where A is 1, and another group for where A is 2. Then we can apply a function, let's say sum, to column C for each of those groups, and then we just combine the results. See? Simple.
All right, enough with the theory. Let's get back to our airline mystery and see how this strategy actually helps us build our case and figure out what's going on.
So instead of looking at daily data, our first move is to split the data into weeks and apply an averaging function. And when we combine those results, wow, the pattern just jumps right out at you. Check out that third bar for almost every airline. The week ending December 18th was an absolute disaster.
Now this pattern is a huge clue, but it's not the final answer. A good data detective's next question is always, okay, but why? The data actually has different categories of delay. Was it the weather? Was it security? Something else? We gotta dig deeper.
So we take just that one bad week, and we split the data again, but this time by the type of delay. We apply a sum function to get the total minutes for each category, and boom! Look at that bar on the far right for nearly every single airline. Late aircraft delay. That is, without a doubt, the overwhelming culprit.
And this is so important. It wasn't just one or two planes that got massively delayed. When we look at the average delay, we see it was a widespread systemic problem. It's that classic domino effect. Planes were arriving late, which caused their next flights to be late, which caused the flights after that to be late. It was a cascade of failures rippling across the entire country, pointing to some kind of major operational breakdown that week.
So aggregating the data like this gives us the what. But to really tell the story, we need powerful visualizations. We have to move beyond simple charts and show multiple layers of information all at once.
The most basic way to look for relationships is a scatter plot. You put one variable on the x-axis, another on the y-axis, and you just see if a pattern shows up. It's an absolutely essential tool, but it's only showing us 2 dimensions of what could be a much, much richer story.
But what if each of those little points on the scatter plot could tell us more? This is the key insight. Modern tools let us encode more data right into the visualization by changing the properties of each point. We can change its color, its size, even its shape.
And the difference is just it's night and day. On the left, you've got a standard 2D plot. It's fine. But on the right, that's a 4D story. We're looking at data about flowers here. The point's X and Y position tells us the sepal length and width. But now, the color tells us the flower species, and the size of the dot tells us its petal width. We are literally seeing 4 dimensions of data for every single flower, all in one glance. That, my friends, is data storytelling.
So let's just recap. We went from a really messy chart of flight delays all the way to a clear culprit,
And we've seen how to build much richer visualizations. So let's wrap up what we've learned as data detectives today.
So, what are the big takeaways? First, split, apply, combine is your fundamental technique, your secret weapon for finding clues in the noise. It lets you start broad, find something weird, and then zoom right in on the details. Second, visualization isn't just for your final presentation, it's your magnifying glass during the entire investigation. And by using things like color and size, you can turn a simple chart into a rich, multidimensional story.
And this strategy isn't just for airline flights. It works on sales data, scientific measurements, website traffic, really anything you can put into a table. The principles are totally universal. So the real question I want to leave you with is this: what story is hiding in your data, just waiting for a good detective to come along and find it?